Okay, so in this video, we'll discuss about Coulomb's law of electrostatics. We have basically two laws of electrostatics. The first law, we'll talk about the first law for in this video, and we'll continue to the second law maybe in another video. Okay, so what is first law of Coulomb's law of electrostatics? Like charges repel each other and unlike charges attract each other. In other words, body having same charges repel each other and body having opposite charges attract each other. The first law tells us only about the nature of force, that is, they are repulsive or attractive. It does not tell about the magnitude of force. The magnitude of force between two charged body is given by the second law. The second law of Coulomb states that the force of attraction of repulsion between two charges is directly proportional to the magnitude of the two charges and inversely proportional to the square of distance between them. This is F is equals to K into Q1 Q2 upon D square. This is also known as Coulomb's law of electrostatics. We'll discuss about this law further, but in this video we'll focus more on the absolute and relative permittivity and the unit charge. So by unit charge, we mean that 1 Coulomb charge. By Coulomb's second law, F is equals to Q1 Q2 upon 4 pi epsilon naught d square Newton. So F will be equals to 9 into 10 to the power 9 Newton. And Q1 and Q2 is Q. So epsilon naught is 1 and epsilon naught 0 is 8.854 into 10 to the power minus 12. The distance we take as 1 meter. Putting everything in the above relation, we get Q2 as plus minus 1 coulomb. So hence the unit charge or the coulomb charge in SI system can be defined as the much charge which when placed at a distance of 1 meter from an equal and similar charge in air is repelled with a force of 9 into 10 to the power 9 newtons from it. In CGS system, 1 coulomb is 3 into 10 to the power 9 stat coulomb. So this is the unit of charge is stat coulomb also. So we'll talk about absolute and relative permittivity. Permittivity is basically the property of particle medium which affects the magnitude of the force existing between 2 point charges. We have discussed before that the greater value of permittivity of the medium placed between the two charged bodies, the lesser the value of force existing between them. So every medium is supposed to possess two permittivities, right? Absolute permittivity and relative permittivity. We have discussed epsilon naught 0 and epsilon naught r in the above equation. So the absolute permittivity of air or vacuum is minimum and its value is 8.854 into 10 to the power minus 12. Whereas the value of absolute or actual permittivity epsilon naught of all other insulating medium is more than epsilon naught 0. The ratio of these two permittivities, that is absolute permittivity or insulating medium to the absolute permittivity of the air or vacuum, is known as the relative permittivity of that medium and can be denoted by epsilon naught r. Epsilon naught r is equals to epsilon naught upon epsilon naught 0. So epsilon naught will be equals to epsilon naught 0 into epsilon naught r.